This talk is going to give a brief introduction to my thinking about instrument and interaction design as an artistic practice, focusing on human-object relationships and the social contexts that frame these interactions. We will wind our way through a forest of various points of interest, traveling towards what I think of as an ecological approach to media performance. As a framework for thinking through these ideas, I'm drawing on my own artistic practice and the research that went into a course called Situated Instrument Design that I developed some years ago at UC Berkeley's Center for New Music and Audio Technologies, or CINMAT. The class was centered on the instrumental system design research of David Wessel and Adrian Fried at CINMAT, and the ideas that flowed from their innovative work in the theory and practice of human-computer interaction and real-time electronic sound, based on David Wessel's background in cognitive science and free improvisation. Like Wessel, my own background in music came largely through the practice of improvisation, and in many ways I think of composition and the process of developing instrument systems as different modes of instrumental practice. And this experience of instrumental performance, forming close relationships with objects, has proven to be a key element in developing a holistic and open-ended framework of what the idea of instrument means or could mean. Okay, so what is an instrument exactly? Is it a mechanism, utensil, appliance, equipment, device, contraption, contrivance, gadget, gizmo, a form of labor-saving technology? The Oxford Dictionary defines an instrument as a tool or implement, especially one for precision work, a means of pursuing an aim, a person who is exploited or made use of, a measuring device used to gauge the level, position, speed, etc. of something, especially a motor vehicle or aircraft, an object or device for producing musical sounds, also musical instrument, a form or legal document. So I think it's interesting here that music is not the first meaning. Also interesting is that none of the definitions really seem complete. They're all somewhat circular, referring to other synonyms that were in our list. We learn that an instrument is a type of tool. Okay, but let's see if we can follow the path of definitions until we find something general enough to think about multimedia. When we look up the word tool, we learn that a tool is a device or implement, especially one held in the hand, used to carry out a particular function. And then if we look up device, we see that a device is a thing made or adapted for a particular purpose, especially a piece of mechanical or electronic equipment. So here we have a thing. A thing is a useful idea and seems to give us a lot of leeway to describe as we see fit for a given situation. Since we're talking about instruments in the artistic multimedia context, we want our definition to have room to consider an instrument in as many ways as possible. If we go a bit further, we find the definition of a thing is an object that one need not, cannot, or does not wish to give a specific name to, an inanimate material object as distinct from a living sentient being, an action, event, thought, or utterance. I love this first definition. An object is one that need not, cannot, or does not wish to give a specific name to. So a thing is an object. Besides that, the dictionary can't give it a name, but you may wish to if you feel the need. And here we can see an aesthetic choice starts to enter the picture. Turning to the definition of object, we reach a point of recursion. An object is also a thing. An object is defined as a material thing that can be seen and touched, a thing external to the thinking mind or subject, a person or thing to which a specified action or feeling is directed, a goal or purpose. This dictionary dive is not just an etymological exercise. These meanings can really have a direct and tangible influence in the way that we create and use things in making art. So, the thing object seems to imply something, anything, that is not us, the subjective sensing person. This definition of thing also mentions the sense of an external otherness, which is a deep part of the way we situate ourselves in our environments. But of course, from other people's perspectives, we are ourselves also some kind of otherness. So I think really everything is a thing. When these things are a tool or implement, especially one for precision work, then we might typically call them instruments. And we've learned to do all sorts of different things by interacting with objects. We are doing things with things. Historian and environmental philosopher Melanie Challenger writes in her book, How to Be Animal, A New History of What It Means to Be Human. Quote, life on our planet can be arranged, more or less, into autotrophs and heterotrophs, organisms that exploit energy from the sun or chemical reactions, and organisms that take energy from those who've already captured it. What is unusual about our species is that we've been able to use more and more energy without having to evolve into a different species. We've achieved this through a combination of social learning, complex culture, and technology. We don't have to speciate to gain the claws of an Allosaurus. We can share information to design a warhead or power station. In other words, we change our tools rather than our bodies. End quote. So, in other words, we've evolved through social learning and culture to develop new tools, devices, objects that allow us new capabilities for action and utility. The tools become extensions of ourselves. As Marshall McLuhan writes, during the mechanical ages, we had extended our bodies in space. Today, after more than a century of electric technology, we have extended our central nervous system itself in a global embrace. Artists know this very well, as we must think, imagine, feel, and create forms through the mediation of tools. We call performing musicians instrumentalists, who spend much of their lives devoted to the nuanced control of one particular type of instrument. Each art form has its own set of instruments, paintbrushes, knives, glue, and so I think we can also include every artist as a kind of instrumentalist. For some artists, like dancers and vocalists, the body is the instrument. Or for other media, like works of relational and participatory art, the conceptual framing of the situation and social context might be created through the instrument of language or architecture. Each instrument can become a kind of lifestyle. We tend to identify with our instruments in an intimate way. They are symbolic of different modes of expression, influencing our perspectives on articulation, and like language, mediate our thinking about how different kinds of actions might fit into different social situations. Our bodies also physically change as a result of this close relationship with our tools. String players develop calluses on their fingertips from the pressure of the strings against the flesh. Violinists and violists will often have a little red mark on their chin, and so on. I once broke my arm skiing and had the cast slightly angled so that I could continue playing guitar while it was healing. Luckily, there was no lasting damage from this, but in some cases, instrumental technique can cause lasting damage. For example, brass players, can sometimes be a problem. Some instrumentalists will do extreme exercises thought to improve technique. Robert Schumann famously ruined his career as a pianist using extreme finger-stretching technologies of his day. This intensity of the artist's relationship to their tools is a byproduct of the intensity of the potential throughput in this incorporation of tools with our physical gestures. So there's this deep incorporation stemming from the Latin incorpus, into the body. When we reach a level of fluency with the tool, we don't think about it anymore. It becomes part of us. We know what will happen when we move in a certain way without it being a conscious decision. Action through an instrument becomes instinctual. In the 1980s, there was a famous study by Benjamin Libet, who through a series of EEG experiments showed that the brain registers the impulse to perform a movement before activity in the conscious decision region of the brain is present. Although it was later contested, the study was used by some theorists as proof that there is no such thing as free will, since the body acts before the mind has time to understand. We can also recognize that this reaction on instinct is an important part of instrumental performance practice, which aims to internalize the nuances of action to perform through the mediation of the tool. This expansion of intention through objects could potentially be traced back to the practices we developed as hunter-gatherers. In her book, Challenger writes about studies on the South African San people, who are one of the last remaining hunter-gatherer societies. What began to fascinate anthropologists who studied the San was their meticulous imitations of the animals they hunt. The hunters, in some sense, become animals in order to make inferences about how their prey might behave. This spills over into ritual. The San use hyperventilation and rhythmic movement to create states of altered consciousness as part of a shamanistic culture. In the final stages of a trance, Lewis Williams writes, people will sometimes feel themselves to be turning into animals and undergoing other frightening or exalting transformations. For anthropologist Kim Hill, identifying and observing animals to eat and those to escape might merge into a single process that sees animals as having human-like intentions that can influence and be influenced. Humans are also mind shifters. Not only can we see other things in a single image, we can also see other minds and other things. So the tools we use are an extension of ourselves and evolved with us through social practice developed over 1 million years. I would speculate that our relationship with things is based on our social understanding that other things can be entities with their own agencies. Like relating to other people, relating to other things may also require some psychological ability to read the thought and agency of other non-human things. For example, in this description of hunter-gatherer shamanistic practices, the hunter-artist performs a transformation into the prey or predator using their body and psychological energies as an instrument to help them foresee the actions of the other animal through being them in some way. As we learn to influence and perform with a tool or object or entity, we are learning to understand its unique agency and character, how it responds when we interact in one way versus another. In human-computer interaction, these are often referred to as the affordances and constraints of the system, which describe the ways certain types of actions are encouraged or discouraged by its design. Based on the embodied mind perspective developed by Francisco Varela and others, David Wessel refers to this process of instrumental learning as an inactive process, which emphasizes the role of sensory-motor engagement in musical experience, towards the formation of a human-instrument symbiosis. Wessel goes on to describe the process of learning through the action of babbling, named for this critical role of exploratory vocal experimentation in the development of speech in infants, as they learn to connect sounds with the physical process of producing the sound. One of my other mentors in instrument design was the late Joel Chataby, who expressed a similar contextual perspective of learning through action, which he likened to sailing on a stormy sea, where the sailors have to adapt and learn how to balance and maybe even steer the ship as the waves and wind toss them around. So this is a bottom-up approach where knowledge is developed first through action versus a top-down perspective where plans and ideas are constructed and then executed. Improvising musicians are good examples of practitioners who are deeply involved with the generation of material from the human-object relationship. Derek Bailey writes, although some improvisers imply a high level of technical skill in their playing, to speak of mastering the instrument in improvisation is misleading. The instrument is not just a tool, but an ally. It is not only a means to an end, it is the source of material, and the technique for the improviser is often an exploitation of the natural resources of the instrument. Let's keep thinking through the history of this idea of instrumental agency. In his book, A Million Years of Music, musicologist Gary Tomlinson discusses some of the current theories of the social and cognitive context surrounding one of the oldest known tools of the Paleolithic era, the Acheulean biface. The remarkable symmetries formed in these early human-shaped rocks seem to imply a high level of planning to achieve this level of detail. However, archaeologists have determined that rather these tools predate our modern conception of planning and thinking at a distance. Tomlinson writes, "Preconceptual action sequences are structured according to these material affordances, the energy required in working with them, and the biomechanical limitations of the worker. And all of these together can be enough to engineer systematic patterns tending to produce material symmetries." From this vantage, thinking of the hominin mind dictating symmetries has it backwards. It is the body-stone interaction from which symmetries and perhaps even the mind emerge. The variability of raw materials, more than varied conceptual plans, will lead to the variability in tools produced, as well as varied embodied thought. There is a rich and provocative opportunity glimpsed here of reversing our habits in conceiving early hominin experience. It is not that stone tools are proxies of the mind, but something closer to the reverse, mind as an outgrowth of the body-stone interface. And so here we confront a powerful idea. Our conceptual development, which has driven humans' evolution of tools as extensions and modes of expression, was possibly the result of an active performance practice, rather than any kind of sudden flash of cognitive advancement. Tomlinson continues, "Such performative sociality requires little thinking at a distance. It is closely related to conceptions of embodied cognition that resist the Cartesian separation of thought from matter and emphasize the situatedness of cognition in material matrices extending out from the body." So as we move, exploring this material matrix that connects our bodies with our tools and environments, we are feeling our way through and learning through trial and evaluation of the material and forming a cognitive system, moving from the details towards a higher level thinking at a distance. And so when we perform with an instrument, we are in a way creating a new symbiotic body material matrix, a relational network binding together an assemblage of objects and entities. Each element has its own character, ways of moving, affordances, and constraints, and their own layers of agency in the process. Our bodies are also internally functioning through the agency of many different life forms, incorporated bacterias, inherited virus DNAs, and so on. But yet our minds generally seem to produce a unified experience of the world. In a way, we might read our deep involvement with objects as an externalization of this principle of symbiosis, where our minds subtly include other life and objects into our sense of self. The history of human ritual and mysticism is full of examples of people finding ways to extend and access different parts of themselves through the use of tools like masks, costumes, paintings, dance, and music, which are all processes which act to embody the subjective self into an expanded instrument body persona. The expansive experience of human body symbiosis can also be a tool for fighting for agency in situations where one's physical body has been subjugated by an oppressive force, as addressed in feminist and critical race studies. For example, the early Afrofuturist work of Sun Ra, Parliament Funkadelic, and later with the advent of hip-hop, beatboxing, turntablism, techno music, and so on. Philosopher Akila Mebe writes, Afrofuturism is not simply content on shattering the illusion of the properly human. Rather, according to them, the Black experience defeats the very notion of the human species. Produced from a specific predatory history, the Black is essentially a human refashioned into a thing, forced to endure the same fate as that of an object or tool. Because of this, The black has become bearer of a kind of human grave. He is a wraith who haunts the delirious fantasies of Western humanism, itself having become a kind of crypt to house the souls of all those forced to share the fate of objects. With such a rereading in hand, the Afrofuturist movement declares humanism henceforth obsolete. If one wants to adequately grasp the contemporary condition, the Afrofuturists contend, one must do so from all the assemblages of human objects and object humans, for which, since the arrival of the modern era, the black has been both prototype and prelude. For, once blacks erupt onto the modern world scene, there is no longer a human who is not already enmeshed in the non-human, the more than human, the beyond human, or the otherwise than human. End quote. And so in this way, the Afrofuturists and post-human lines of thought towards the non-human is a way of decentering the human as defined by a culture of oppression. Similarly, in critical ecology and animal studies, there is an effort to correct the unconscious anthropocentric bias that is encoded into almost all aspects of modern culture, working to counter the myth of human supremacy found in many religions, which, as Challenger discusses in depth, suggests to anthropocentric humanists that as a human, we are fundamentally superior to other animals, and maybe not even animal, but rather may be placed on earth by God as owners of the land. So our collaboration with objects and other non-human agencies has been a key factor in our evolution as a species. And yet, eventually, there has been this tendency towards working against the perceived agency in non-human things and other humans. This bias of human exceptionalism and supremacy seems wrapped up with our instinct towards tribalism, which has helped our species defend against competing groups and predators, and also acted as a catalyst promoting strong social bonds and collaboration within a trusted group. With the advent of agricultural techniques around 10,000 BC, humans increasingly applied a logic-based methodology to harvesting their food resources. Rather than an interactive encounter with non-human entities, where both participants are understood to have agency in the encounter, agriculture relies on strategic thinking that aims to domesticate the other. The other, then, becomes further separated from ourselves and our tribe until eventually humans deemed themselves somehow separate from the rest of the earth, forming the difference between wild nature and human society, and eventually to form up a human supremacy. Timothy Morton speculates that this development of agricultural logistics acted to, quote, sever the humans from the biosphere. Morton writes, "What the severing names is a trauma that some humans persist in reenacting on and among ourselves, and obviously on and among other life forms. The severing is a foundational, dramatic fissure between, to put it in stark Lacanian terms, reality, the human correlated world, and the real, ecological symbiosis of human and non-human parts of the biosphere. Since non-humans compose our very bodies, it is likely that the severing has produced physical as well as psychic effects, scars of the rip between reality and the real. One thinks of the Platonic dichotomy of body and soul, the chariot and the charioteer, the chariot whose horses are always trying to pull away in another direction. The phenomenology of First Peoples points in this direction, but left thought hasn't been looking that way, fearful of primitivism, a concept that inhibits thinking outside agrologistic parameters." End quote. And so, the nature of this agrologistic approach is a focus on an isolation of parts, so that each element can be logically reasoned and strategically organized. As we can clearly see in history, this is an extremely powerful way of thinking, and provided the basis for our eventual development of computational systems. However, when combined with biases of human and cultural supremacy, the logistical approach can also lead to oppression and devastation. For example, the histories of ecocide and slavery. Returning to Attila Mebe's reflection on Afrofuturism, he writes, "The Afrofuturist repudiation of the modern notion of mankind is nevertheless surprising. Does it not ultimately reinforce certain ways of thinking rooted in the flagrant denial of Black humanity? Let us not forget that since the start of the modern era, we have dreamed of becoming masters and owners of ourselves and of nature. To achieve this, we needed to know ourselves, to know nature, and to know the world. From the end of the 17th century, it was thought that the best way to do this was to unify all domains of knowledge and to develop a science of order, of calculation, and of measurement that would facilitate the translation of natural and social processes into arithmetical formulas. With algebra having become the means by which one models nature and life, a modality of knowledge has gradually been imposed that consists essentially in making the world flat, that is, to homogenize the entirety of all living things, rendering these objects interchangeable and manipulable at will. This process of flattening the world, spanning many centuries, has been the governing motivation behind a substantial part of modern knowledge and cognition. This flattening movement has been accompanied in various degrees and with incalculable consequences by the other historical processes typical of modern times, namely capitalism and the global zones created by capital. Since the 15th century, the Western Hemisphere has acted as the privileged engine of this new planetary venture, and it has been propelled throughout by a system of mercantilism and enslavement. On the basis of triangular trade, the entire Atlantic world was restructured. The great colonial empires of the Americas emerged and consolidated themselves, and thus began a new era of human history. One concrete example of this homogenization process is discussed by Gavin Mueller in his discussion of the impact of containerization in commercial shipping. He writes, "This was the impact of containerization, the technological standardization of shipping by enclosing all cargo into uniform metal crates. Containers were intermodal. Crates could be loaded by crane directly onto or off of ships via trains and trucks. This meant the end of the laborious loading and unloading of the cargo by hand, piece by piece. Containerization completely upended the dock system. Not only were fewer dock workers required for the containerization parts, but by drastically reducing loading and unloading times, and therefore making the shipment of goods dramatically less expensive, fewer ports were needed. Many cities, including New York, saw their waterfronts and their associated communities decimated in just a few years. But the revolution didn't stop at the docks. As transportation of goods was no longer cost prohibitive, manufacturing could be located wherever labor costs were lowest. It could be centralized, since there was little need to relocate production closest to consumption. Containerization was the essential precondition for what became known as globalization, where production is scattered along far-flung international supply chains. Containerization was not driven solely by industry needs for efficiency, but also by a military order. Indeed, without containerization, Levinson argues that America's ability to prosecute a large-scale war halfway around the world would have been severely limited. In fact, the Vietnam War was instrumental to early processes of globalization. After dropping their material in Da Nang, container ships stopped off in Japan to fill up with electronics before returning to the West Coast." End quote. So, after the process of containerization, the dock workers no longer knew what was inside the boxes. Their focus was shifted from managing the direct transfer of the content to the mediated transfer of standardized containers. And it is the same process of containerization that is the foundation of computational systems of data processing. Shifting back to the musical perspective, we can trace some of the same types of technological abstraction in the evolution of keyboard instruments. The keyboard is a homogenized interface that triggers a sequence of mechanical actions which combine to make the sound we hear. Organs, for example, are controlling windpipes and reeds, whereas harpsichords control a plucking mechanism. A clavichord pushes a metal blade gently into the string, and a piano has a striking escapement mechanism. Each keyboard instrument feels slightly different to play, with different actions and sense of weight to the keys. However, they all share the same basic 12-note per octave keyboard design. In the late 19th century, it was therefore an easy transition to introduce electronics into organs and other keyboard instruments. The keyboard and equal-tempered chromatic scale were the same, only the mechanism that performed the sound in response is changed. Equal temperament itself is another example of homogenation, which leads to an increased modularity, for example, the relative equivalence when transposing a chord from one key to another. In the context of digital systems, this homogenation is taken even further. The input and output of the system, if human readable, will be some kind of sensory media, sound, image, touch, etc. However, between the input and output, the signals are converted into binary data. For example, in digital signal processing, a microphone first translates sound pressure waves traveling through the air into voltage fluctuations. The fluctuating voltage is then digitized by an analog to digital conversion, which reads the voltage values at regular intervals and records the sequence of values as a series of numbers in a memory buffer. Each byte of data is only a value. It has no context by itself. Once stored in memory, knowledge of what type of information is stored at a given memory location is required in order to give meaning to the data. In the sound or image file, there is usually a header included which declares the type of the file and other metadata regarding the contents. And so, in the computer, this context itself is just another block of values, and which also has to be read in a defined way. For instance, using a file format extension code which is recognized by the operating system. This characteristic flatness of data creates a blurring of media boundaries, similar to shipping containers and the way in which a commercial synthesizer keyboard can switch from one sound to completely different sound by selecting a new preset. Gestures stored in data can just as easily be interpreted in a totally different media context, albeit with different aesthetic results. For example, the famous Aphex Twin piece using Metasynth to perform a photograph of a face as a frequency spectrum. Within the world of data, the operating system functions as a virtual ecosystem filled with daemons and WC3 specifications through which the data gains definition of type and clearly defined protocols for how the regions of data should be read and evaluated. The digital environment within the computer is purposefully abstracted in design that aims for maximum efficiency and computational flexibility through the polymorphic nature of homogenized storage containers. I think it's important also to remember that computers are, at the lowest level, still a physical system, shrunken to ever smaller dimensions, but really are not so different from a very complex synthesizer. And also, the history of computation is closely connected with musical instruments. For example, some of the earliest forms of binary representation used for mechanical operations can be found in the hole punch techniques used first in the mechanical looms dating from 1725, developed by Bastille Bouchon, the son of an organ maker. Later, the mechanical loom was further developed by Jacques de Vaucanson, who was famous for creating automata of a flute player and a digesting duck before working on the loom mechanism. The hole punch system was then later modularized in the developments of Joseph-Marie Jacquard, who in 1804 patented a system that used interchangeable cards to create a sequence of threading patterns. The punch card technology was later used for early computers and developed into smaller and smaller form factors. In the 1950s through the 1970s, magnetic core memory was used. The Jacquard loom provided a fully automated mechanism which allowed for the creation of highly detailed textiles, reducing the required work with the machines to simple manual labor without any need for skill or expressivity. Having arrived just after the Napoleonic Wars, this further aggravated the struggling livelihood and culture of French silk weavers who greeted the Jacquard loom by attempting to assassinate its inventor and destroying the device publicly in Lyon. The mechanism continued to spread, however, and was a driving force in the Industrial Revolution, causing a major upheaval and devaluation of traditions of master weavers in the name of industrial production of capital, which flowed upwards, of course, to the owners of the machines. Meanwhile, the skilled artisans were no longer needed, but rather low-wage workers who were required only to manage the functioning of the machines, which resulted in the hollowing out of the middle class still visible today. And so the knowledge of how to move between different sequences of woven thread was encoded into a binary punch card representation, which was then performed by the mechanical looms. From an instrumental perspective, we can see that the more layers of mediation there are in an instrumental system, the more opportunity there is for the designer of the system to embed their own understanding, aesthetics, and desires into the tool's inner workings. As Thor Magnusson writes, "The objects around us, the technologies that serve as props in our thinking and music making, are stuffed with people and their ideas. In them, we find programs of action, manuals of behavior, and political and socio-cultural constructions, including aesthetic tendencies." I love this idea of objects being stuffed with people and their ideas. Thinking about this the other day, I took a walk in my neighborhood and suddenly started seeing the history in all of the objects around me. Each object has this backstory contained in it that gives it its character. For example, a candy wrapper laying on the ground has already been through so much. The raw materials, the paper and wax, all have their histories. And then the design of the wrapper to fit the candy, the machine that makes the wrappers, the graphic designers, the children choosing the candy at the candy store. And so when we're thinking about the forms and meanings of objects and instruments, we're also examining this embedded history and ideas about the nature of the objects and how they might function in some social or physical context. Okay, so let's take a look at what makes up an instrumental system, keeping these histories we've been discussing in mind. In a traditional acoustic musical instrument, there is a performer, the instrument, and the acoustic as well as social spaces where performances take place, since, as we've learned, all instruments are situated in a context. For example, violins in the 19th century were designed to project sound much further than earlier instruments due to new technologies and to adapt to the larger halls being used in performances. To perform a note on a musical instrument, the performer uses their body to interface with some element of the instrument construction. On a violin, this might mean with the right arm, hand, and wrist drawing a long strand of rosined horsehair along a wound metal string, causing it to vibrate, while pressing the fingers of the left hand downwards on the strings so that the vibrational length of the string is shortened and changing the pitch. The vibration of the string is transferred through the bridge and sound post of the instrument to the body of the wood, which resonates and amplifies, transferring the string vibration to the various surfaces and materials that make up the instrument, which in turn transfer the vibration to air pressure waves, which radiate outwards spherically from the instrument into space. Each type of instrument has different modes of activation, resonance, and vibration, which give it its characteristic timbre. And the different materials and manners of interaction give each instrument a unique tactile character, which influences the performance and interaction. For example, a metal string pressed into the fingertips is a very different experience from pressing the smooth keys of a flute. Also, there is a big difference in experience between using the lungs and lips to shape airflow to vibrate a column of air as compared to using a bow to vibrate a string. And so here we can see the affordances of these different performance techniques. For example, the nature of the wind and embouchure techniques required to make a tone on the flute contain an affordance for highly nuanced variations over the duration of the tone. Drawing on the mechanism used for vocal performances of speech and singing, flutists control the speed of airflow and shape the resonance in the mouth through manipulating the tongue and embouchure, and probably other parts that I'm not aware of. As a note is sustained on the flute, the instrument provides an interface between the wind control system of the body and the vibrating column of air in the resonant tube. The key mechanism of the flute provides other affordances. For example, the springy action of the keys affords rapid trill figures. A constraint of the flute is that you have to hold it in a certain way and focus the air from the mouth in the right way to activate the vibration of the air column. For example, an affordance of the violin is that you can play more than one note at a time, since there are more than one string, whereas this is a constraint of wind instruments in the traditional sense, ignoring multiphonics for now. Another affordance of the violin is the smooth shifting between notes. Since there are no frets, the finger can slide along the string to create glissandos. The key and valve mechanisms of wind and brass instruments are some early technologies for expanding the range of the instrument. However, in the development of the keyboard instruments, we start to see an even more extreme process of mediation in the instrument design. With keyboard instrument designs like the organ, harpsichord, piano, etc., the keys act to trigger a secondary action which performs the actual physical activation of the vibration. The performer then no longer needs to know about or directly manage the mechanical process of striking or plucking or the resonance of the instrument, but rather should focus on the techniques of pressing the fingers down on the right keys at the right time, and the mechanics inside the instrument take care of the rest. This abstraction has some powerful affordances. As we have seen, if this type of design is applied within the framework of colonial capitalism, it can have a devastating effect on people's lives. Inside a piano, the effect is more contained, affecting only felt and metal wires. However, the point is that these ideas are not separate, but are a basic application of the same logistical approach to design. In the current era of computational everythingness, the line tends to be blurred at the boundaries between which types of design are harmless and which act to constrain the life of the users of the program. By the way, did you know that when you identify elements in a reCAPTCHA I'm not a bot test, that you are actually working for Google? I just found this out recently. They realize that rather than having you type in some handwritten digits by reading a picture, as in the original CAPTCHAs, which by the way stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart. So Google realized that they could use the public as unpaid workers to produce semantic image labeling of the that are there in the image, like recognizing cars that are, click on all the cars, click on all the ladders. This is training the image processing and the artificial intelligence systems that are now being able to categorize images, thanks to our helpful clicking. So the point to keep in mind here is that any design, like the architecture of a building, has an effect on the people using it, and that the instrumental contexts that integrate mechanical and computational processes, the design process results in an increased agency of the engineer on the results of the system. So, getting back to musical instruments, here's a diagram borrowed from the great composer Agostino di Scipio, outlining the basic flow in an interactive music system. The diagram is centered on digital music systems. However, I think it is equally applicable to mechanical systems like the piano and organ. As in mechanical systems, computational instrument systems function through a mediation between the interaction interface and the media production, which in the case of music is usually sound. But in multimedia context, the output could also be other media. The performer interacts with some kind of sensing device, which converts the gesture information into voltage, which is then sampled and quantized to produce normalized data which can be interpreted by the computer. Like David Wessel, Di Scipio is also following the embodied cognition theories of Varela and describes an interactive approach to instrument design, emphasizing the cybernetic feedback loop, which includes the performer's reevaluation of the output of the system, as well as the acoustic environment which situates the interactions. And so the performer is in a feedback loop, acting and reacting within a system of agencies, including the affordances and constraints of the physical interface, as well as those of the mechanism of the computational part of the system. The computational logic is embedded into the system as an act of composition, encoding the aesthetics, knowledge, and biases of the author, who makes assumptions and predictions about the future interactions of the system performed by the instrumentalists. In many ways, we can also draw parallels to the work of John Cage and Morton Feldman here, who developed open and semi-open forms of composition which function to control certain parameters of performance while leaving others open to other agencies. David Wessel's variation on the instrument system design model further illustrates the role of the human performer in the feedback loop. Implied also in Wessel's diagram is a mirroring action of the generative algorithm with the human performer's cognitive process of enactive learning. The computational algorithm responds to the gesture input through a process of interpretation that connects with the programmed expectations of the types of gesture that it might receive, based on, again, the human programmer's own set of enactive experiences. For the situated instrument design class, I also made a variation of Wessel's diagram, which introduced some more details showing the flow of data within the computational blocks of the instrument system. I also added the process of composition into the model. The instrument system depicted here is what Joel Chadovy used to call a composed instrument. As high-performance personal computers became more widely available, artists have gradually gained a higher degree of programming fluency, and more are able to implement the designs of instrument programs themselves, which previously required a specialist engineer who would mediate the ideas of the artist. Considering composition itself as being a performative action, an action of creating later actions, we can see at least two layers of composition in the system. First is the act of composing the framework of the system as an instrument for computer-assisted performance, which creates or manipulates media in response to the performer's action, perhaps received from a sensing device. The second order of composition can occur when the system also provides tools for the user to compose presets or customized mappings. In this case, the system might be considered as a tool for computer-assisted composition. For example, a software platform that provides the user with tools that produce new musical sequences based on the values set by a graphical user interface, for example, in a digital audio workstation, or using generative processes for producing material. And so a computer-assisted composition system is itself a kind of instrument that the composer performs with, which produces some kind of score-like media. And again here, there's a strong influence of the design of the system, which dictates the possible outcomes that the user is able to produce. These are the affordances and constraints of the system. For example, a music notation program that requires the user to specify a rhythmic meter forces the user to think in terms of rhythmic subdivisions, and so on. Thinking of composition as a performance practice, we can look again to, for example, to Cage, Feldman, and Earl Brown, and many others who used paper as an instrument of compositional performance. For example, Earl Brown's graphic scores and Cage's Music for Piano #1, where he used the imperfections of sheets of paper to figure out where the positions on the spatial locations of musical events would be on the page, or Feldman's practice of setting up perfect grids of measure on each page, and also always writing with ink. So these are all of these processes are creating affordances and constraints that the composers are performing into the score media. Further, in the cases of participatory art, or what Nicolas Bourriaud refers to as relational art, we might also consider an instrumental system which functions in a framework of social interaction, where the media includes the interaction of the participants, rather than only a media that the audience experiences in a more sensory kind of way. Or, for example, the acoustics of a room will have a strong effect on the way people talk to each other, as they're adapting their voices to be heard or less heard depending on the room's reverberation and the level of speech intelligibility and the social situations. Maybe they don't want to be heard, and the acoustics are broadcasting their voices everywhere. In this way, an artist might instrumentalize the acoustics of the space to shape the experience of the visitors. And so the architectural, ambient, and social aspects that form the context around an artwork all have a clear agency in the audience experience of the work. The inclusion of other agencies into the artwork can also be seen in works that involve animals. For example, Joseph Beuys' famous piece where he locked himself in a room with a wild coyote, or the works of Robin Mayer, who is often working with different varieties of animals and insects. For example, his work with Ali Momeni, where they glued mosquitoes to microphones in a non-harmful way and played them vocal music, and the mosquitoes interpret that sound as a potential mate and tune their buzzing to the same frequency. In these cases, maybe the definition of instrument could be problematic. Is an animal a media? Maybe I think of these pieces as relational works that combine the agency of the human and the non-human. Through the programming of complex, multi-layered, and nonlinear interactions, computational systems can sometimes be understood as acting on their own. Rather than functioning as an extension of the human performer, the relationship to the human is as a meeting of individual entities. The aesthetic and behavioral knowledge has been composed into the system, and then is considered as a separate personality, acting with its own computational agency. George Lewis describes his work with artificial intelligence improvisation systems in this way. He writes, "In Voyager, The computer system is not an instrument, and therefore cannot be controlled by a performer. Rather, the system is a multi-instrumental player with its own instrument. In this sense, it is useful to consider Robert Rowe's taxonomy of player and instrument paradigms, although I regard the two models of interactive role construction not as a fixed binary opposition, but as a continuum along which a particular system's computer-human interaction can be located. End quote. And so we can see that in some cases, the system built with the knowledge and skill of its designer encoded into its inner functioning with unpredictable and nonlinear mappings might shift categories. No longer a tool to be controlled, it rather becomes an entity in itself who acts with a high level of agency in its interaction with other agencies. This idea of composing a system as a character who performs a role also has a connection with automata and strong AI. From the perspective of the human-object relationship, we can still view the creation of an autonomous performance system as an extension of the creator's imagination of how this character might act and interact with others and its environment. And similarly, in an instrument system, the performer works in collaboration with the object, extending the performer's sense of self. As they learn to perform with the system, it becomes more and more natural and second nature to coordinate their gestures in connection with the media output. In both cases, there is this process of creating a sense of persona, character, that is closely related to the practice of puppetry, where there is also a rich tradition of this human-non-human symbiosis. In terms of multimedia, I think of puppetry as the basic principle of mechanical and computational systems that produce media through this collaborative interaction with the performer. This can also take the form of a digital or mechanical performance. For example, the works of Jean Tagli or Laszlo Moholy-Nagy. While in an acoustic musical instrument, there is generally a more direct connection between the actions of the performer and the physical vibrations of the instrument body. In the context of computational instruments, the performer is interacting with a system of mediated actions. And so the compositional process of the instrument design focuses largely on the mapping of information from the input context to the output context. What kinds of media performance should result from a given data input? How do the perceptual qualities of the sensing interface relate to the perceptual qualities of the output media? How should the audience read the relationship between the gesture and the resulting performance? What kind of experience does the performer have with their instrument? And how does the design of the system affect the types of expression that are possible? By composing the mediation, we're also building the affordances and constraints of the system, which in turn form the possible relationships that the performer might develop with the instrument. Thinking then from the audience's perspective, we can view the design of an instrument system through the relationship that forms between the performative actions and the resulting media that is created. To consider the relationship between sound and image, we can maybe take a quick look at some of the discussions surrounding the use of sound in early cinema. As synchronized sound playback technology became usable, filmmakers like Sergei Eisenstein began to think critically about how sound influences the art of visual storytelling tools of editing and linear narrative. This is a huge topic which we don't have time to go into very deeply, but greatly simplifying, we can focus on the problem of the perceived inner speech of the character on screen as intuited by the audience versus the outer speech that is created by the synchronized sound, which gives a sense of realistic speaking of the character and requires a different, possibly less active engagement of the audience. One of the most despised approaches in early cinema was Mickey Mousing, where the musical accompaniment is composed to directly correlate with the movements on the screen. This direct correlation creates an audible obviousness to the relationship between sound and image, which, due to its highly literal orientation, has an effect that disrupts the flow of the narrative in a more slapstick kind of way. Jean Cocteau says, "Nothing, it seems to me, can be more vulgar than musical synchronism in films. It is, again, a pleonasm, a kind of glue where everything gets stuck rigid and where no play, in the sense of play in wood, is possible." End quote. However, even though there are many examples of filmmakers criticizing the redundant use of music to amplify a visual movement, as cinema continued to develop into the sound age, it did begin to incorporate the use of environmental and sound effects, which were established earlier in the context of radio plays back in the 1920s. In the cinematic practice of the Foley artist, artificial sounds are created in the studio and synchronized with visual movements in order to create a sense of realism in the scene. For example, in many films, there are continuous audio tracks added to most scenes to fill in the sounds of doors, footsteps, and fabric moving with the characters on screen, which gives a sense of naturalism. The Foley artist creates a representational relationship of sound to the objects and actions on screen. In Mickey Mousing, on the other hand, motions on screen are depicted in the form of musical sound, which function within the framework of abstract musical structures of pitch, height, and rhythm. And so, through this process of abstraction from the actions of the screen, the musical representation has an effect of flattening the meaning of the image. Sounds in the real world are produced by the interaction of physical objects and spaces. So, in the case of a representational sound, the sound acts to reinforce the natural physical event, while an abstracted sound acts to recontextualize the event from the natural impression into musical space. Through his experiments with tape recorders, Pierre Schaeffer's development of musique concrète explored this tension between the representational and abstracted processes in sound. For example, similar to some principles of montage theory, Schaeffer studied the importance of the attack transient in our ability to recognize the source of a given sound, produced acoustically by its characteristic relationship between the physical objects of its construction. By removing the initial moments of a sound and fading into the resonant continuation period, Schaeffer was able to abstract the sound from its source, and through recombination could then mask the identity of one sound using the transient of another source. Tape recorders also provided the possibility to shift the pitch of the sound by changing the playback speed, further altering its representational meaning. In the context of mediated instruments, this representational aspect of sounds also plays a large role. In many electronic and digital instrument systems, there is a skeuomorphic process at work, where the instrument sound synthesis process is designed to produce the sound of another familiar instrument. For example, when designing an electric piano, the electronics will usually be designed to produce the characteristic attack, sustain, decay amplitude envelope of an acoustic piano. In a digital signal processing context, this might be achieved through the use of a physical model, which mimics the activation and resonance processes that are active in a physical system. As digital technologies were becoming dominant in the 1980s and 90s, an aesthetic of glitch music emerged through the work of experimental musicians like Yasono Tone, Nicholas Collins, and the band Oval, who used skipping CDs as sound materials. In the works of these artists, system malfunction became the voice of the instrument. Working in a similar vein as artists like Christian Marclay, who created loops with skipping and sliced vinyl records, the sounds used by Tone and Oval's skipping CD players are a distinctly digital flavor of malfunction. Through this focus on system malfunction, glitch foregrounds the material body of the system itself. A typical commercially produced technology is designed in a top-down process, functioning to produce some target result while hiding the actual structure of the system out of the user's view. When the inside is purposefully inaccessible or unreadable, we call this a black box. For example, a CD player is designed to spin a compact disc at a certain speed and uses a laser data sensor to read the bits of audio sample data encoded on the surface of the CD. The sample values are read and then stored in a digital buffer. And then an internal clock is used to perform the sample data at a given sample rate, sending the sample values through a digital to analog converter, which converts the data to voltage fluctuations, eventually becoming sounds when the voltage fluctuations are converted to sound waves by the speaker transducers. But of course, usually no one is thinking about this sequence of actions when listening to a CD. We're listening to the sounds, just like turning on the radio or playing a vinyl LP. The technological system that is in play in these three cases are all totally different, but the user experience is quite similar. So by causing the read head of the CD player to skip, these artists intervened into the physical action of the system. No longer do we hear the sample data in sequence to produce the sounds as intended by the makers of the CD, but rather the disruption causes the system to reassemble the information on the disk into a new sequence. This starts to shift our attention away from the encoded content of the CD and instead to the process of the CD player's buffering algorithm. And so glitch can be thought of as a technique of producing real sounds that are embodied by the material system that produces them, rather than a reproduction of abstracted or representational sounds. So this is a very reflective and active approach, which has the effect of fracturing this illusion created by the media system, a kind of Luddite action that widens the experience of the media to also include the details of the system that produces it, and potentially the assumptions and biases encoded into the system by its designers. We can connect these ideas also with earlier works, for example, the Duchamp ready-made, and in particular the works of John Cage, for example, the works for prepared piano. In each case, glitch creates a kind of second-order conceptual metasystem that shifts from a focus on the products of the system to artifacts created by the design and construction. In the visual domain, we can see similar approaches in Nam-June Paik's Magnet TV, where he used a magnet to disrupt the functioning of a television, and Joan Jonas's Vertical Roll, where she used the rhythmic shifting created by a usually incorrect setting of the television's vertical hold circuit as part of the framework for her piece. Another good example is Jimi Hendrix's use of feedback and the experimental electronics of David Tudor and Dom Buchla. This increased awareness of the larger systems at play was everywhere in the 1960s and 70s and was a major driving force of the counterculture movements. Glitch seems to take two main approaches, either disrupting part of a functional black box system, for instance, like Hendrix's use of high-gain amplification or Nam-June Paik's Magnet TV, or on the other hand, working from a bottom-up structural approach, interacting with the inner workings of the system itself. For example, we can see this structural approach in the works like Tony Conrad's The Flicker film, which used the alternating frames of film projection technology as an instrument for a kind of retinal music, and Yanis Xenakis' S709, where he uses dynamic stochastic synthesis techniques to directly generate sample data. Sashiko M's work with sampler test tones and extreme frequency ranges is another good example of shifting the focus of listening and experience from a virtual space of artificial narrative towards a realist material experience of digitality and the boundaries of physical perception. So each instrument system has its own character with its own set of affordances and ways of malfunctioning due to its construction. By studying the results of artifacts of system malfunction, we can learn how the system represents itself. For example, a digital system can be represented with extremely accurate rhythms, exact repetitions, extremely short notes, precisely tuned frequencies, aliasing due to the Nyquist sampling frequency, and the ubiquitous frequency domain compression garbling noise. While glitch is often associated with computational and mechanical technology, the work of artists like Milford Graves and Keith Rowe similarly deconstruct the instrument using artifacts of the systems as artistic materials. And of course, the work of musique concrète instrumentale composers like Lachenmann and Chirino would fit into this category. Similarly, we can view the long-form works of Lamont Young, Morton Feldman, and Charlemagne Palestine as durational glitches of the listening experience, which work by shifting the listener's perspective to larger sculptural systems of space and emergent psychoacoustics. The developments of fluxus happening, installation, performance, and conceptual art were all ways of expanding the perceptual frame of the artwork to include the surrounding context, reflecting on the system of production as part of the work itself. So, thinking back to sound, glitches, mistakes, artifacts, and non-standard methods of performing on instruments tend to produce noisy and complex sounds, which have a high degree of contrapuntal components within the sound, since the performance actions are no longer in accordance with the design of the instrument, most commonly designed to produce clean, idealized tones for the performance of Western classical music. Instead, the modes of vibration and resonances are altered by the performer, and so rather than foreground the top-down performance of pure tones, the system vibrates in an alternative orientation. From an artistic point of view, I find that I am almost always firstly focused on the timbre and texture of a sound that I'm working with, and drawing the motivic phrasing from a perspective of tactile listening. Is the sound smooth or rough? Spiky, with sudden rhythmic increases and decreasing in volume, or more consistent flowing in texture? Are there clearly defined layers to the sound? For example, a slowly moving, low rumbling with a higher sporadic moving frequencies above? Is it dry or liquid sound, hot or cold? And so what I think of as tactile listening is a kind of focus on the feeling of texture and finding the rhythmic and motivic possibilities that are there in the sound in a very inactive, embodied, bottom-up way. What I found very useful was to relate my experience of tactile listening with David Wessel's work on timbre space and David Huron's texture space, using two-dimensional plots to show relationships between perceptual factors. This connection between spatial and sonic form is also very related to the idea of puppetry, where the puppeteer works to create a sense of a living entity by relating the voice of the character with the movements of a sculptural form. Unlike natural-sounding bodies, the puppet's voice is usually physically separated from the body. In classical puppetry, the puppeteers are usually hidden and then synchronize their voices to speak at the same time as the puppet moves its mouth. As in theater, the voice of the character gives us information about who they are, and the puppeteer's performance through the object is able to read the feelings and story of the character through the movements. Puppetry is, in a way, one of the oldest forms of multimedia instrument design, and when done well, creates a strong sense of human-object symbiosis. In a series of recent works, Apophenie, Scenes from the Plastosphere, and a new piece, Animism, which will be premiered later this year, I've been working with the development of video puppet instruments, which fuse digital and organic bodies as a way of attempting to create new connections between humans and non-human experience. In the situation constructed by the instrument, the performers use their hands, usually hidden from view, to manipulate objects and organic textures, which are viewed through a high magnification macro lens and live video capture. When projected to a large scale, the miniature details of the organic texture seem to become all different kinds of strange animals, plants, or more abstract materials of liquid or lab-like environments. The video image stream is then analyzed by a computer vision algorithm, which outputs various informations about the image as interpreted by the different algorithms. For example, the speed of the motion of an object, or its morphological character, size, orientation, and the quality of its contour. Is it jagged or rounded, color, and so on. When composing for this context, I generally first experiment with different physical materials and see how different types of movement and texture work on the screen, trying different angles of light, different camera framings, and improvising with the material, feeling which ways of movement in the scene have the most control or expressivity, and studying the resulting scene for traces of characters that might emerge from the movements and environments. In some cases, the character of the scene is a landscape, for instance, or a crumpled up piece of paper whose fibers are slowly absorbing water and causing the paper to change shape over time, like a time-lapse video. Or perhaps the character of the scene is the physical presence of the screen itself, or the movement of the camera or lights might be the character. I will usually work out what kinds of actions will happen on the screen, potentially bringing in plot narratives or symbolic transformations based on the possibilities of the physical materials. In many cases, I'm working with very organic, hard-to-control materials, and so the composition of the actions tends towards a kind of framed aleatoric approach, where many details of the action are unspecified, but rather defined by more general performative descriptions. Once I have the sequence of actions figured out, I will generally break the sequence into scenes and try to find effective computer vision analysis approaches that will make sense for the different textures and scenic contexts of each situation. For example, in scenes with a solid white or black background, it is easy to isolate a shape in the image from the background. Whereas in a scene with a highly detailed environment, it requires either some kind of background subtraction pre-processing or using another approach like optical flow to separate the performed object from the background. After finding a computer vision analysis approach that connects with the motion and scenic material, I then develop the voice of the characters by mapping the computer vision analysis to various digitally controlled sound processes. Since by nature, the camera puppet instrument is a highly mediated system, the relationships between the sound and image becomes very important. Loosely drawing on the ideas of Foley, I will often study my perceptual experience of following the tactile qualities of the objects on the screen and try to identify what expectations I might have about the kinds of sound that an object might make in the real world. Often, I will make use of glitch-type approaches in order to create sounds that reinforce these intuitive experience of haptic texture in connection with a feeling of digital embodiment within the objects. And so through this tactile listening approach, I create a kind of realism between the experience of the object and its sound produced by the digital system. The human performers are working to form a close relationship with the objects and their actions captured by the camera. The instrumental puppeteers have to look deeply at the actions on the screen and adjust their physical movements to emphasize the characters that they see there. As they attune to the character, it speaks through the computer. So there's this projection of feeling from the puppeteer into the object's body. The performer feels themselves acting through the objects, but at the same time tries to feel from the perspective of the object, creating an extended body between them. The computer is studying the object and uses its composed embedded knowledge to connect sounds with the analysis of the object. Because the materials are organic and not totally controllable, the performer must constantly be engaged and adapt to the agency of the physical materials. And so this piece is a kind of an ecologically minded attempt to decenter the human as the primary subject of performance, and instead tilts the focus towards the object and the larger context of human-non-human interaction and symbiosis. One of the goals of this piece, which is potentially unattainable, is that somehow, by bringing the attention towards the non-human actors, that the audience will have a greater sense of connection and empathy with the other human and non-human entities that are all around us everywhere. Since, ethically speaking, this subconscious bias of human exceptionalism, cultural supremacy, and tribalism have caused so much damage to other lives and the planet's biosphere. The hope is that people will experience some sense of opening in this tendency towards self-protection and defensive isolation. As Timothy Morton writes, worlds are perforated and permeable, which is a way we can share them. Entities don't behave exactly as their accessor wants them to behave, since no access mode will completely shrink-wrap them. So worlds must be full of holes. Worlds malfunction intrinsically. In conclusion, I'd like to read a quote from Antonin Artaud, who was deeply thinking about the human-object relationship. He says, "Once aware of this language in space, language of sounds, cries, lights, onomatopoeia, the theater must organize it into a variable hieroglyph, with the help of characters and objects, and make use of their symbolism and interconnections in relation to all organs and on all levels. The question then for the theater is to create a metaphysics of speech, gesture, and expression in order to rescue it from its servitude to psychology and human interest. But all this can be of no use unless behind such an effort there is some kind of real metaphysical inclination, an appeal to certain unhabitual ideas, which by their very nature cannot be limited or even formally depicted. These ideas, which touch upon creation, becoming, and chaos, all are of a cosmic order and furnish a primary notion of a domain from which the theater is now entirely alien. They are able to create a kind of passionate equation between man, society, nature, and objects."